All right, the last section we're going to cover this year is 10.7. We're going to skip up to chapter 10, plane curves and parametric equations. Pretty much what this is we're going to now, instead of just talking about x's and y's, we're going to introduce t, typically for time when it comes to word problems, so that's going to come in the second part of this video. So we're going to express x's and y's in terms of a third parameter, a third thing called t time. And so we're going to do the first example. I'll talk you through it, and then we'll get into a little bit more with the trig that's going to come. So the first thing we need to get used to seeing is we need to get used to seeing two different functions, x and y, both expressed in terms of t. Now again, that's typically time, but for now let's just call it t. So when you're doing a problem like number 1, we got to fill in the chart completely, and I'm going to give you a restriction for t. So in this one it says -2 to 2. So when you're filling out your chart, you want to start with filling in your t values. So I want to go -2 all the way up to 2. Now typically I like a few negatives, few positives, so I just kind of fill in between the two and I get these numbers here. Now what we're going to do is we're going to take each of these t values and plug it first into the x equation up here and then into the y equation. So if I do the first one, and maybe I'll just show a little bit of work on the first one, but then maybe not so much after that, I would say x is 3. Okay, I'm going to plug in -2 for t and square it, I get 4. And if I actually multiply that out, I get 12. All right, if I do the same thing for y, y is 2. And then a -2, and I get -4. So the first set of coordinates on this one would be 12, -4. Okay, and if I do that with the next one and all the ones down, so I'm just plugging into x, plugging into y, here are the coordinates I get. Same thing for y now. And yes, we do have to fill these charts in completely. And then I'm going to come over here, fill in all the coordinates. Okay, so it's a little tedious, but it's not hard. Now, here's where the kind of interesting part comes in. First, we're going to graph these. Now, a rough sketch is fine, and sometimes on these problems, you don't exactly know how to connect the dots, so you're actually going to do part B of the question before you even graph them, okay? But for now, let's just go ahead and jump in. Let's see what this might start shaping up to be. All right, so on these, we're only going to plot the x and y, not the t. So if I plot the first value, it says 12 on the x's, -4 on the y's. All right, and to some extent, this can be a rough sketch. All right, and then 3, okay, so if I split this in half, that would be 3, and then -2, and then 0, 0, and then 3, 2, and then 12, 4. Okay, so at first glance, I'm not exactly sure how to connect these dots. Is it squared off? Is it rounded? What's going on? So now let's talk about part B. If I take the original equations up top, I'm just going to rewrite them so they're right in front of us. All right, x equals 3t squared, y equals 2t. Now I want to know, how can I get rid of the t and only write things with x's and y's? So the goal is to get t by itself in one of these equations and then plug it in or substitute it into the other one. Now, looking at the y equation, I would say getting t by itself on this one is going to be way easier, all right, because I just have to divide by 2. Whereas if you try to do it on the x equation, you'd have to square root and divide by 3, which is fine, but it's best to take the easier route. All right, so now I have t is the same as y over 2. All right, so let me take this guy, plug it in up here. Now I get x is, and I have a 3, and then instead of t, I'm going to write y over 2. Now let's clean this one up just a little bit. I get x is 3y squared over 4. And it's been a while since we've talked about this, but let me just give you a quick refresher. If it's y squared and it's positive, it should be a sideways parabola. So now that kind of helps me connect these dots. It's going to be a sideways parabola. And it stops. There's no arrows on the ends because of the restrictions of t. Now, something I want you to get used to adding, though, I want you to connect the dots in the order in which you plotted them. So if you have this, it kind of has a direction around the parabola now. All right, let's do a very similar one. Okay, so we're going to choose values of t. Here's my restrictions for t. t greater than 0, so I'll start with 0, or sorry, greater than or equal to 0. Now, when you start picking t values, sometimes you have to take a look and see what makes sense. What I mean by that is, if you look at the y equation, y equals root t, it would make sense to pick values of t that are perfect squares. So the next value of t I might pick is a 4, and then a 9, and then a 16, and then a 25. All right, that's going to make plotting these a little bit easier. It also means that I might kind of estimate when I go for the graphing part. Okay, so if I plug all these values into the x equation, I get the numbers. So 0 plus 2, I get 2, 6, 11, 18, 27. Same thing on the y's. Take the square root of all these now. All right, and again, let's fill these in completely. So if I come over here for the x comma y's, here are my points. 3, 18, 4, and then lastly 27, 5. Okay, now on this one, because the points are so big, like that last point is 27, 5, instead of trying to do all the 27 little tick marks, I'm going to answer part B first and see what shape we're even talking about here. Okay, so the original equations, x equals t plus 2, and y equals root t. Now again, let's get the easiest one. When you square root things and square things, it's typically harder, like in the y equation, than just subtracting like in the x equation. So if I just subtract the 2 over, I get x minus 2 is t. So now I can take that x minus 2 and plug it in up here. So then I get y is root x minus 2. So there is my rectangular equation, right? No more t, just xy. And that makes it a little bit easier because take a look. Instead of plotting each of those individual points up there, I'm going to plot the first point, which is 2, 0. Maybe even the second point, so 3, 4, 5, 6, 2. And then you do have to remember what a root x, so here if I do a little sketch down here, remember that root x has that shape to it, and root x minus 2 means you take that shape and move it right to. Now it makes it a little bit easier to sketch the curve. So it's a root function, moved right to, and I connected the dots in that direction. Okay, number 3 involves ease, which means we're going to have to use ln, natural logs. So I want to wait to do number 3 with you in class, okay? So now let's skip to numbers 4 and 5. All right, here's where the trig comes in. Circles and ellipses. You probably remember circles because we just did a few recently, but ellipses you need a little refresher. So let's start with the circle. If it says 0 to 3 pi over 2, that should kind of make sense because that goes along with all the trig we've been talking about. And I would like you to go by half pi intervals. So 0, half pi, pi, 3 halves pi. All right, now on this one, let's not mess with filling in that last one because we'd end up graphing some crazy decimals. I don't even want to mess with that. All right, so if I do those, and then I'm going to plug in the values, each of the t's, and for x and y. Now, if you're not understanding where these numbers are coming from, you can go to your graphing, plugging in, however you want to do it, but I'm going to do that kind of quickly. So if I plug in these values for x, I get these, same values for y, and I get these. And then my coordinates over here. Let me do that kind of quick. All right, so now I have my points. Now, let's see what this looks like. So if I go to my graph, okay, remember I'm graphing in rectangular here. So it goes 4, 0, 0, 4, negative 4, 0, and then 0, negative 4. Hopefully you're kind of saying, oh, that looks like a circle, right? And I'm going to connect them in the order in which I plotted them. And I'm also stopping at 3 pi over 2. Notice I don't make it back to the 0, 0 mark. So it's 3/4 of the circle, not the whole thing. And then there's 2 ways to do this one. I want to do first kind of the way that in case you get stuck. And then if you remember how to do circles pretty well, I'll show you that way too. All right, so I see my equations up top. X equals 4 cosine t. And I'm trying to isolate t, which is really hard with sine and cosine because that means you'd be doing inverse cosine, inverse sine. Okay, let's not mess with that. What if all I did for x equals 4 cosine t is divide the 4 over, and all I do for y equals 4 sine t is divide the 4 over. Okay, now let's remember a little Pythagorean property. Hopefully you haven't forgotten this. Sine squared plus cosine squared equals 1, right? We know that to be true. Now what I'm saying is instead of sine squared, what if I called it y over 4? Okay, and instead of cosine squared, what if I call it x over 4? Okay, and a little bit of cleaning up. Whoops, that was supposed to be an x. X squared over 16, y squared over 16 equals 1. Then one more step, let's multiply everything by 16. I get x squared plus y squared equals 16. Well, and that should make perfect sense, right? Because it's a circle with center 0, 0 and radius of 4. So same deal in number 5, except I've got cosine t with a 1 in front of it and a 4 in front of the sine t. And I want to go 0 to 3 pi over 2 again. So here are my same values, right, by half pi's. And when I do the half pi's, let's not mess with any of that last stuff. And I go and I plug everything in. And hopefully, again, these numbers make sense if they don't ask me in class. All right, same thing for the y's. All right, now we can see these points are a little bit more lopsided. They're not perfectly the same number all the way around. So here's where we get an ellipse. Okay, so now let's take a peek at what that might look like if I did a rough sketch. All right, so I plot the point 1, 0, 0, 4, negative 1, 0, and 0, negative 4. Okay, now once again, don't connect it all the way around because you're supposed to stop at 3 pi over 2. And then here are my directional arrows. Okay, now you can tackle this one the exact same way we tackled number 4 for part B, the rectangular portion. But let's see if we remember how to do ellipses. Ellipses take this form. Something over something plus something over something equals 1. Now this one's centered at 0, 0, so I can just say x squared, y squared. And then in the x direction, so if I come over to my graph here, I went over 1 unit. In other words, a is 1 for ellipses. And the a squared goes under the x's, so just 1. And then if I go in the b direction, I get b to be 4. So b squared is 16. So this would be my rectangular ellipse. All right, on this last page, I want you guys to try number 6. It should be another ellipse. So go through the chart, fill in all your values 0 to 2 pi, graph it, and then find the rectangular equation. All right, and then I want you to leave the rest of this worksheet blank. Now, what I do need to do is I also need you to watch the second video tonight. So I need to close this one out for time's sake, and I'm going to open a new one in a new link.